All right, whenever you're ready, Sarah.
Okay. Uh, let me. Okay. Hi everyone. Our project is called Project Echo, and I'm Soraya. I have been working on this with teammates Christopher and Leonard. Echo is a smart system designed to help households manage their food better. It uses technology like AI and IoT sensors to reduce food waste. The system also supports food donations and composing. So instead of throwing away food, people can either use it more efficiently, donate it to someone in need, or compose it. It's not just an application, it's a full solution that connects user, community, and sustainability in a smart and simple way. Next slide, please. We started by identifying the biggest challenges around the food waste. First, household waste, a lot of food just because they forget what in refrigerator or don't take expiration dates. And second one is even when people have extra food, they often don't donate it because they don't know where to go or it's too much effort. And third one is composing isn't very common. Many people either don't know how or think it's too messy or complicated. There are three problems that are connected, and that's why we built Echo to address all these problems together. Please, next slide. For data collection and analysis methodology, to understand the real needs, we collected data from 26 people, 6 interviews, and 20 surveys. We talked to students, teachers, and janitors and professionals to get a wide range of opinions. Some patterns stood up. For example, people want expiration reminders, and also they are interested in helping others, and many don't know how much about composing. We also studies similar applications like to go, Olio, and some composing tool, but none of them combine all three areas like Echo does. This research helped us shape our future based on real user needs. Next slide. Based on our research, we made a clear list of features. The functional requirements, including tracking food, scanning barcodes, suggest meals, helping user donate food, and connecting with a smart compost bin. The non-functional parts are also important. The application needs to be easy to use, protect privacy, and work smoothly across devices. If every part is connected, for example, when a user scans groceries, it helps with meal planning and alerts, which then connect to donation and composing later. Next slide. Uh, this slide shows the main things a user can do in the application. First is inventory tracking. A user can scan food, see what they have, and get reminder. And second one is meal plan donation. The application help user give away items before they expire. And third one is smart composing. If the food can't be used or donated, the system helps compose it instead of. Echo of this is a use case. A way user interact with Echo to reduce waste and make better choice. Next slide. I think now Leonardo and Christopher can continue this presentation.
Okay, Thank you, Sarai, for opening and introducing everyone to our Project Echo concept.
Mhm.
Hi, I'm Christopher Morgan, and I'll be discussing the difference between our past DFDs. A physical DFD transforms the logical processes into actual system components, showing how the system will be implemented with specific technology and components. The key difference between a logical and physical DFD, the physical level 0 DFD, I've created transform the logical model into implementation specific components. Number one, the main process implementation. Instead of just showing a logical process, Project Ecosystem, the physical DFD specifies it as a mobile app, for instance, iOS, Android, with distinctive modules pertaining to inventory, donation, composting, and notifications. Number two, data store implementation. Rather than generic data stores, it shows a specific cloud database implementation. Number three, external interfaces. This shows actual hardware components like the smart compost bin with IoT connectivity. Number four, integration points, uh, which adds external APIs for food information and composting guides. Number five, technical flows, show specific data changes rather than general processes. For instance, API requests rather than just requests. Number six, infrastructure details. This indicates how the system will be deployed. You guys there? Okay, it shut off for a second. Okay. Back to what I was saying. Number six indicates how system will be deployed via mobile platform with connectivity cloud services. The physical DFD gives stakeholders and developers a clear picture of how Project Echo will be implemented in terms of actual technology components and their relationships. Next slide, please. The physical level one DFD explains for Project Echo, it expands on higher level view by showing the specific technical implementation of each logical component. The key physical components, one would be food inventory module that consists of an implemented native mobile module with integrated barcode scanner API. It also connects to an NoSQL food database for storage. This interfaces with external food data API for detailed product information. Number two, expiration alert systems. It implements a push notification service that is also integrated with cloud messaging platform for delivering alerts. Once these alerts are received, it gives users expiration data from inventory module. Three, donation management systems. Community exchange module with integrated mapping capabilities that is connected to a dedicated donation listing database that interfaces with location services for proximity-based matching. Composting assistant, IoT integration module using Bluetooth low energy, for instance, BLE connections. This system communicates with smart compost bin hardware that stores composting progress in time series databases. Five, sustainability tips. Sustainability tip one is an AI-powered recommendation engine. It analyzes users' behavior and composting data, then delivers personalized sustainability advice. User authentication, implemented using OAuth 2.0 and Firebase authentication. It manages users' profiles database and provides access control for all modules. Then there are data stores. These stores are composed of D1, user profiles, DB stores user account information, D2, NoSQL, food DB, flexible scheme database for food inventory, D3, donation listings DB that manages donation offers and requests, D4, time series compost DB that tracks composting data over time, and last but not least, external systems that compose of Food Data API, which provides nutritional information and food details. It also has cloud messaging that handles push notification delivery. The external system also offers location services that provides proximity matching for donations. Smart Compost bin IoT hardware device with sensors. This physical level one DFD provides developers with specific technical implementation details while showing stakeholders how the system components interact with each other and with external systems. Next slide, please. For Project Echo, we implemented a cloud-based client-server model that perfectly balances computational efficiency, scalability, and flexibility. This architecture provides coherent coordination of our key system features: AI-powered food tracking, IoT-enabled composting, and community-based food donation functionality. On the client side, our web and mobile applications handle presentation logic, creating an intuitive user experience. Meanwhile, cloud-based service manage data storage, application logic, and data access, leveraging environments like AWS, Azure, or Google Cloud, or dynamic resource scalability without requiring extensive on-premises infrastructure. A particularly innovative aspect is our use of edge computing for IoT integration. The smart composting bins process sensor data locally before transmitting insights to the cloud, enabling real-time responsiveness and reducing latency. This architecture offers several crucial advantages: scalability to accommodate growing user demand, cost-effectiveness through cloud deployment, enhanced security with encryption and authentication protocols, modular design for independent upgrades, and ease of maintenance. AI-driven analytics for predictive food exploration modeling. By implementing this architecture, Project Echo establishes a viable, scalable platform that effectively integrates food inventory tracking, community-supported food distribution, and smart waste management, all work together to create a comprehensive food solution for waste. Next slide, please. Our conceptual data model is built using classy entity relationship diagram notation, providing a logical representation of our system's data structure. This diagram captures the core entities, attributes, and relationships before any technical implementation. We've carefully designed it to reflect the real-world relationships between users, food items, and waste management processes. Looking at our key entities, the food item entity forms the backbone of our inventory tracking system, storing critical data like name, category, purchase date, and expiration date. This connects to user's entity in a one-to-many relationship. As one user can manage multiple food items, the user entity serves as our central hub, connecting to food items, donations, and compost records. Our donation and compost entities track waste reduction efforts, while the recipe entity enables our meal suggestion functionality. We've implemented intersection entities like donation item and recipe ingredient to manage many-to-many relationships efficiently. Finally, our physical database schema translate these logical concepts into actual database tables with specific data types and constraints. Here you see the tables with clearly defined columns, primary keys, and foreign key relationships. We've optimized this scheme for performance and scalability, ensuring it can handle group users' data while maintaining query efficiency. This physical implementation supports all the functionality shown in our data flows diagrams, from scanning brochures to managing donations and composting activities. This comprehensive database architecture provides the foundation of Project Echo mission to reduce food waste through smart inventory management, donation facilitation, and composting guidance. And that ends my presentation on slide 9. You can take it over from here, Leonard.
Thank you, Christopher. So now I'm going to be talking about the prototype and our window navigation diagram, which maps out how users move through the main screens in the Project Echo, and it shows the structure and flows of user experience. So starting from the login screen and moving through core features like food inventory donation, and to donate food. Basically, we wanted to make something that was simple, simplistic, and easy, intuitive for users to use. The diagram helped us plan out our logical layout, and before we started designing the actual screen. So, like you can see from the home screen, you can navigate to food inventory donation to donate food or to compost. So let's say you went from food inventory straight to the store, you can scan an item and you can choose whether you wanted to store that food for yourself at home and look at your own inventory, or if you wanted to go straight into donating food and looking at local shelters to maybe process that food out to and which foods to actually donate. Or maybe you just really wanted to compost the food and show and put that into your app. And possibly you're thinking about creating some kind of reward system for doing for composting things around your neighborhood. These are just ideas that we thought of. But the Venn diagram just shows those steps in a more simplistic manner. Next, we can move to the mobile prototype. Oh, shit. The prototype. So this is a more thought out layout that Christopher made. This is our mobile app prototype. This is designed to reflect the real user experience based on our Venn diagram. This design focuses on simplicity and clarity for users managing food waste and donations. I can walk you through one of our core cases. So let's say you're logging in through the food inventory from home and then you scan, you just click on the user tab screen and you can scan an item, enter that into your grocery details, and the app automatically schedules alerts before expiration dates. And from there, you can either consume, donate, or compost that depending on the status. This layout is really built for mobile users that kind of want to do this on the go. So in other scenarios, we can say, let's like I can give a scenario for like let's say Christopher comes back from the grocery store and he opens up the Project Mobile app, Echo app, and instead of typing each item in manually, he can just scan the receipt feature, and from there, every item that he's bought that can be stored on the app as far as food inventory goes goes up on his app. Now he can pick and choose what he wants to keep and or wants to donate and or wants to compost. So, a few days later, he'll get a push notification telling him, oh, your spinach, maybe his spinach expires in 2 days, and he can tap that alert, and Project Echo can suggest 3 healthy recipes for him that he might want to do. In another scenario, maybe Soraya wants to In another scenario, maybe Sawyer wants to donate unopened perishables to someone that she deems in need or like to a shelter that she supports. Um, she's cleaning out her kitchen. She can literally go into her inventory screen on the app, select donate items, and she can select 5 items for food to nearby she can select 5 items that she wants to donate, and it'll bring up nearby shelters that she's either already donated to or could possibly start donating to, and it can kind of start like a chain effect of just things that she might want to do in the community, and um that's basically like the premise of the app is basically a community app to help not only you but the people around you um basically get involved with um things that are in your own home and like and donating to shelters and helping other people as well as helping yourself. So to evaluate our position in this space, we created the SWOT analysis, which stands for strength, weakness, opportunities, and threats. Our biggest strength is timing. This is a growing eco-conscious movement, and the technology for mobile apps, sensors, and AI is already available and already out there in big and large numbers. This puts Project Echo in a strong position to make the impact. And then our main weakness that we face is that it requires behavioral change from people, and it requires people to understand that Project Echo kind of is an app that's bigger than just one person. It does take a community of people to not only use it, but use it correctly and use it in a way that makes an actual change. People aren't always in the habit of tracking or donating food, and some people might think it's kind of tedious, but we'll need to make that process as easy and rewarding as possible. That's why we have when we did our surveys and interviews, we asked people what are things that would actually make you want to donate on the app and actually want to take the time out of your day or busy schedules to make a difference. There's a lot of opportunity through local partnerships with schools, food banks, or other sustainable programs, and even government subsidies for eco change and eco tech that could support Project Echo and really make people or more, I should say, encourage people to do um, Project Echo and make Project Echo work. The one threat that we have is cost, both for users and buyers, compost bins, and maintaining the platform. And since we're collecting user data like donation history, there are some privacy concerns, but we really encourage people not to worry about that because Project Echo isn't like a tracking app. We're not tracking your data to give it away. It's more just tracking your data so that it can take that um take that out of your subconscious mind that, oh, maybe I have something, maybe I don't. You can literally just look on the app, almost like your pantry and fridge all in one on the go. And you'll never really need to have to think about what you have or don't have again. So key lessons learned. One of the key lessons One of the key lessons learned from developing Project Echo is the importance of user-centered design in tech products, especially in sustainable focused applications. So through interviews and surveys, it became even clear that the tech-savvy users often struggle with food waste due to the lack of intuitive systems. This was reinforced a critical industry insight. No matter how advanced the technology is, its success is only hinged on accessibility and usability. Another valuable takeaway that we took from this project is it relates to data integration and system inter interportability in industries leveraging IoT and AI like agriculture, homes, and waste management. Seamless communication between sensors, apps, and cloud databases is essential, and our work on smart composting within Project Echo taught us that building scalable architectures are crucial, and it's not just for functionality, but for long-term existability. We also learned that through sustainability and technology, we must align with real world incentives. While many users care about reducing waste and uh, adoption skyrockets when paired with features like donation tracking, gamified programs, and potential tax benefits, like we suggested to our interviews and through our quizzes to ask people and surveys what they would like. Lastly, we saw firsthand the necessity of cross-functional thinking. Project Echo wasn't just about building an app; it required about thinking like product managers, understanding market positions, and aligning development with both user needs and technical feasibility. So this experience closely mirrored how real-world startups and product teams operate within tech companies. So as far as the future of Project Echo goes, we plan to start by creating a brand identity kit. So the logo that we have at the beginning of the project is just a mock, claiming a color palette and other colors to match trustworthy tech-forward feel and clean typography. That's what we would like to do so that people feel comfortable using the app. We also talked about designing a small, simple icon version of the logo for mobile users and or browser users. After that, we want to build a demo video and clickable prototype using tools like Lucidchart or Figma, showing basic user needs and maybe something also like a little bit more 3D so that people can see and actually click on icons and see how it works and use the scanning feature. And then we would create like a one-page summary of all that that quickly explains what Project Echo is and how it works. Oh, and how it works. In plain language and what kind of positive impact that it will have for users. You know, beyond the basics of those things, we would also map out features that show scalability like point tracking and dashboards, and then also creating a few samples using personas. Like Sophie, a freshman who donates meals plans monthly, or James, a senior who struggles financially and receives donated meals. These personas will help us keep the design user focused and show that we're always thinking beyond just building a system. Um, Altogether, this approach should make Project Echo feel polished. And looking forward, we plan on using these tools and easy to present for grading or for future development opportunities. So, yeah, that's what Project Echo is. Um, my name is Leonard Navarre. Um, Working with Christopher Morgan and Soraya Makatari, and this is our project. So hope you liked it.